Hello everybody, Justin here. I wanted to make a quick video about the solubility rules for ionic compounds, and I'm pretty sure there are plenty of other YouTube videos out there that explain this. However, the way I learned a series of acronyms or mnemonics that I haven't seen anywhere else on the internet, and I think they're pretty useful, and they're a very efficient way to learn the solubility rules for ionic compounds. So I'm going to show them to you guys. Keep in mind this is only for ionic compounds. These do not apply to any other types of compounds. So let's begin. The first is NAACP number 1. This is pretty simple to remember, especially if you know NAACP. That's a very prominent civil rights organization, and pretty much everyone in the US learns about them from a young age, and so this acronym is already drilled into your head, but it can also be used to memorize the solubility rules. NAACP number 1. And these stand for nitrates, acetates, ammonium compounds, chlorates, and perchlorates, as well as the group 1 metals. What this means is any kind of ionic compound that features one of these groups, one of these ions, is going to be soluble no matter what. So let me just write them out so you know exactly what we're talking about. The nitrate ion is NO3 minus. Acetate is C2H3O2 minus. Ammonium, NH4 plus. Chlorates, keep in mind this is chlorate, not chloride. There is a difference. Chlorate is ClO3 minus. Be sure not to make the mistake and think that is simply Cl minus. Perchlorate is ClO4 minus. So these two you have to be very careful with. These are not at all Cl minus. That's a different solubility rule. And finally, you have the group 1 metals. You can just look at your periodic table for this. Li plus, Na plus, K plus, Rb plus, Cs plus, Fr plus. All of these will be soluble no matter what. Soluble does not mean complete dissociation. Just keep that in mind. These are only solubility rules. But if you see any of these compounds, if you see any compounds that feature these polyatomic groups, or in the case of the group 1 metals, ions, you can rest assured that it will be soluble in water. Our next mnemonic is BIC minus MLS. So if we have an ionic compound with bromide, Br minus, iodide, I minus, or Cl minus, this is where Cl minus comes in, okay? Don't confuse this with chlorate or perchlorate, which are in the previous solubility rule. This is where the chloride ion, anion, comes in. If you see any ionic compound with these as the anion, they will be soluble in water, except when the cation is mercury, lead, or silver. These are the 3 exceptions that will make these 3 halides insoluble. Otherwise, they will be soluble. And our final rule is anything with the sulfate anion. So sulfates are going to be soluble except in the presence of calcium, barium, strontium, and our friends from the previous rule, mercury, lead, and silver. I should have written the ionic formulas for these. Okay, so That's it. These are the 3 solubility rules you need. Just to recap, NAACP -1, number 1 rather, all soluble. BIC are always soluble except when bonded to MLS, and sulfates are soluble except when bonded to MLS and CBS. If they do not fall under any of these rules, you can generally assume that that ionic compound will be insoluble. Notice how we have not touched carbonates? That's because carbonate compounds are almost always insoluble, or generally insoluble. We haven't touched phosphate. Phosphates are also generally insoluble. So this is, in my opinion at least, a very useful tool that you can use to memorize the solubility rules, and I haven't seen it anywhere on the internet, so I thought I would share it with you guys. Now, just to make sure you got it, let's do some practice problems. So here I have 7 different ionic compounds. Remember, ionic compounds only. And I want you to pause the video and see if you can tell me if they are soluble or not. So you can pause here. Okay, so now I will reveal the answers as well as why they are correct. So, NaOH, sodium hydroxide. If you want to try to practice naming the compounds, go ahead. NaOH is sodium hydroxide, and it is soluble because of this sodium ion. Remember, NAACP number 1, group 1 metals are going to make an ionic compound soluble. So sodium hydroxide is very soluble in water. Next up we have KClO3. This is potassium chlorate. And maybe if you're still new to more advanced chemistry, you might not have realized that ClO3 is the chlorate ion. But you should have known that potassium is a group 1 metal. That means that it is immediately soluble in water. However, even if you didn't know potassium was soluble, potassium makes ionic compounds soluble, the chlorate ion is also in the NAACP number 1 rule, and so no matter which way you look at it, this compound is very soluble in water. How about this next compound, sodium carbonate? Well, you might have known that carbonates are generally insoluble. However, that is overruled by the fact that it has sodium. And we know that sodium makes things very soluble. It follows the rule NAACP number 1. My advice is if you're taking a test or solving problems, always write down the solubility rules, the 3 solubility rules in a corner, and that will help you a lot. How about this next one, calcium carbonate? Well, we have a carbonate, which is not mentioned in any of our rules, and we have a calcium ion, which is also not in any of the rules as being soluble. So therefore, we can call this compound insoluble in water. How about the next one, NH4Cl? This is ammonium chloride. Ammonium is one of the A's in NAACP. This is soluble. Next one, Agcl, silver chloride. Well, remember, chlorides are soluble except in the presence of mercury, lead, and silver, or not in the presence, but when they are bonded to it. And here we clearly have a silver bonded to a chloride ion. This is going to be insoluble. Now, a little note on Agcl. It is more complicated than this. If you have a solution of Agcl, let's say we have some Agcl powder and we put it in water, some of it will dissolve. But that's a little bit more complicated than what we're talking about in this video. Just know that in general, this compound is insoluble, and for all intents and purposes, it doesn't dissolve in water. Finally, we have lithium perchlorate. The perchlorate anion already makes this soluble following NAACP number 1, as does the lithium. So this is another very soluble compound. So now moving on to something a little more complicated, but still doable with the knowledge in this video. We want to see if a precipitate will form from this reaction. So if you want to try this out, you can pause the video. Otherwise, I will move on to solving it. So the first thing to note is that this will be in solution. So the first thing we would do is write out the complete ionic equation. So break everything up into their ions, Na plus, OH minus, H plus, Cl minus. So these are the constituent ions. I shouldn't have probably written the arrow because that makes it look like that's what it's reacting into. And then this is a double displacement reaction. And so in theory, right, we would see something like this forming. However, note that this NaCl is soluble in water following our first solubility rule, and this is just water. This is an acid-base reaction, so water forms. So this is a soluble compound, and remember, precipitates only form when something insoluble forms in reaction. Therefore, we can conclude that no precipitate, I like to write precipitate as PPT, forms. Secondly, we have another double displacement reaction, silver nitrate plus sodium chloride. Again, we can break this down into the constituent ions. And now we can perform the double displacement. So Agcl plus NaNO3. Well, this has the sodium cation and the nitrate anion. Remember NAACP number 1, our first solubility rule. This is a very soluble compound, so no precipitate will form from this particular compound. However, note that here we have to deal with another solubility rule, BIC minus MLS. We have a chloride bonded to a silver, and that's not going to be soluble. This is going to be insoluble. So yes, there will be a precipitate. Yes, precipitate. And to be precise, what will precipitate out is silver chloride. Okay, last but definitely not least, we have potassium chloride reacting with silver nitrate. So again, we can break this down into its constituent ions. If we were being precise, there would be a 2 here, coefficient of 2. And then we would, oh, that's my bad. We would perform the double displacement. Ooh, plus PbCl 2. This was not a balanced equation. I'm just going to balance this really quickly. 2Cl. This would have to be a 2 over here. There we go. This makes perfect sense. I just forgot the coefficients when I was writing this problem out. If you caught that, good job. And so now we can apply the solubility rules. Well, according to NAACP number 1, this is going to be very soluble because you have a group 1 potassium, K+, and you have a nitrate. However, over here, we have to apply our second solubility rule, BIC minus MLS. We have a chloride Sure, but it's bonded to lead. And so this is going to be insoluble. So the answer to this one is yes, there will be a precipitate. And to be specific, that precipitate will be lead chloride. Lead 2 chloride to be specific, because this lead has a charge of +2. So if we're being very, very specific, we're going to write this out as lead 2 with the Roman numeral, chloride. Chloride. All right, so that was just a video about a neat trick I learned to memorize the solubility rules. I'm going to write them out again if you just want to copy them off the screen. NAACP number 1, nitrates, acetates, ammonium compounds, chlorates, perchlorates, and group 1 metals. These are always soluble. BiC minus MLS, bromides, iodides, and chlorides are always soluble except when bonded to mercury, lead, or silver. And finally, sulfates are soluble except when bonded to mercury, lead, silver, or calcium, barium, and strontium. So yeah, I hope this method helped. I hope this method is easier for you than however you learned this, because I personally find this trick to be very useful in determining solubility. So thank you so much for watching.